Hello, hi everyone, coming to my channel Samuel Flying Birds. Today we are going to discuss about quadratic equations of chapter 5 related to 10th class. Here we are going to discuss about nature of roots. In the last class we have discussed about roots of quadratic equation like alpha plus beta and alpha into beta, such that sum of roots and product of roots. Now in this video we are going to discuss about how to find the roots of a quadratic equation based on their expressions. In the previous section we have seen that roots of equations ax square plus bx plus c equal to 0 are given by x equal to minus b plus or minus root b square minus 4ac by 2a. Now let us try to study the nature of roots. Remember that those zeros are those points where values of polynomial becomes 0, or we can say that the curve of quadratic polynomial cuts the x-axis. Similarly, the roots of quadratic equations are of those points where curve cuts the x-axis. In this first case 1, if b square minus 4ac is greater than 0, then we get two distinct roots like minus b plus root b square minus 4ac by 2a minus b minus root b square minus 4ac by 2a. These are the two roots which are being followed. In such case, if we draw corresponding graph for the given quadratic equation, we get the curves as follows. The figure shows the curve corresponding to quadratic equations cut the x-axis in 2 points at two distinct points like minus axis and positive axis, and in the considering in the imaginary axis. In the three ways they are being pointed at two distinct points. In case 2, if b square minus 4ac equal to 0, the x equal to minus b plus 0 by 2a, where the points are lying on the x-axis at only one point, like x equal to minus b by 2a and minus b by 2a are only one point we are going to plot. If the points are similar and repeated, we need to point only one point on the axis. Now coming to the third case, if b square minus 4ac is less than 0, there are no real roots. Here the points are not being touching on the x-axis. We observe the following roots or the graphs given below, such that there is no point touching on the x-axis. Now coming to the next, in this case the graph neither intersect nor touches the x-axis at all, so there are no real roots. If the graph is not touching on the x-axis, it means that there is no real roots. Now we know that b square minus 4ac determines whether the quadratic equation ax square plus bx plus c equal to 0, where a is not equal to 0, has real roots or not. B square minus 4ac is called discriminant of the quadratic equation. For the first case, two distinct roots, real roots, are formed by the condition b square minus 4ac if it is greater than 0. In the second case, two equal real roots are being found if b square minus 4ac is equal to 0. There is no real roots in the third case if b square minus 4ac is less than 0. All this we have been observed in the above cases. Now we are going to solve some of the example problems. The first problem, the it is taken from the textbook. Now, here the problem says find the discriminant of the quadratic equation 2x square minus 4x plus 3 equal to 0 and hence find the nature of its roots. We have to find the roots of the given quadratic equation. Here, how many roots are being formed we have to determine by using the quadratic equation formula based on b square minus 4ac. Coming to the solution, the given equation is in the form of ax square plus bx plus c equal to 0, where a equal to 2, b equal to minus 4 and c equal to 3. Therefore, the distinct formula is given as b square minus 4ac equal to, we need to substitute the values of a, b, c in the given formula. After substituting, we get minus 4 whole square minus 4 into 2 into 3 equal to, we get 16 minus 24 is nothing but minus 8 is less than 0. So the given equation has no real roots because minus 8 lies on the left hand side of the x-axis. Now coming to the next problem, find the distinct of the equation, discriminant of the equation 3x square minus 2x plus 1 by 3 equal to 0 and hence find the nature of roots. Find them if they are real. We need to do all the two methods here, two steps in this problem. In the previous problem, we have find only the roots. Here, we are going for next step. If it is real, we have to find what are the roots. Coming to the solution, comparing the above given equation with the quadratic equation as x square plus bx plus c equal to 0. If we compare, we get here a equal to 3 and b equal to minus 2 and c equal to minus plus 1 by 3. So the discriminant formula is given as b square minus 4ac. We substitute all the given values in the given formula as minus 2 square minus 4 into 3 into 1 by 3 equal to, we get 4 minus 4 equal to 0. Here the b square minus 4ac is equal to 0. By the third condition, by the given condition, we can say that hence the given quadratic equation has two real equal roots. Now we have to find the roots because the equation is equal to 0, so we know that there are two roots present in the equation. Coming to the formula, minus b by 2a. If we substitute, we get 2 by 6. These are the two roots which we get in the quadratic equations if they are real and equal. So this gives that the nature of root where the roots lies on only one point but they are similar, and by this we can complete the complete chapter of quadratic equation. Coming to the summary of both the videos we go through, we have seen in the both videos about quadratic equation. Now we are going to brief what we have been studied apart. Study standard form of a quadratic equation is variable x is ax square plus bx plus c equal to 0, where a, b and c are real numbers and a is not equal to 0. This is the first case which we have studied about the quadratic equation, variables based on variables. Now the second case, a real number alpha is said to be root of the quadratic equation ax square plus bx plus c if a alpha square plus b alpha plus c equal to 0. The zeros of the quadratic polynomial ax square plus bx plus c equal to 0 and the roots of quadratic equation ax square plus bx plus c are same if the values are interchange or the substitution is made, then also the equation is in the same form, so the quadratic equation roots are also same in both the cases. In the third case, if we can factorize ax square plus bx plus c, where a is not equal to 0, into a product of two linear factors, then the roots of equation quadratic equation ax square plus bx plus c equal to 0 and can be found by equating each factor to 0. This is the second case, that we need to find the product of two terms, two linear factors or two quadratic expressions. Now coming to the fourth case, if a quadratic equation can also be solved by the method of completing the squares, as we have did that the roots of the equation like alpha plus beta and alpha minus beta, product of roots, product of two linear factors and sum of two linear factors, we can find the quadratic equation of the roots by solving the completing the square method. Now coming to the fifth method, as we have seen in the present video, quadratic formula based on the quadratic equation x square plus bx plus c equal to 0, where a is not equal to 0, are given by minus b plus or minus root b square minus 4ac by 2a, provided where b square minus 4a is greater than or equal to 0. In the sixth case, we have did based on the sum of the cases based on the quadratic equation. We have considered some of the cases like b square minus 4ac is greater than 0, then we get two distinct real roots. If b square minus 4ac is equal to 0, we get two equal roots, and if b square minus 4ac is less than 0, there are no real roots. In these three cases, we can study how the roots are being varied from point to point. Now, in this chapter, we have learned quadratic roots, polynomial equations, linear pair forms, and finding the roots of the given quadratic expression. And by this, we can complete the complete chapter of quadratic equation. And if any doubts, please mention in the comment box and share this video. Please like, share and subscribe.